Welcome to another informative video on matter measurements brought to you by Autruo. In this series we will be looking at Flowmeter. But before we dive in, let's look at how liquid measurements came to be. Water is one of the most important natural resources. The first recorded liquid flow was traced back in ancient Egypt. Irrigation was a vital activity for survival. As at that time, the Egyptian devised a perfect means of measuring water flow. This discovery leads to some early development in fluid measurements at that time. In 1790, a German hydraulic engineer known as Reinhard Woltman invented a turbine-based flow measurement device. Woltman studied mathematics and hydraulic engineering at Hamburg under Johann Georg Busch. After his studies, he became a civil engineer. And he also traveled across Europe in 1784 extensively after his studies. He earned a reputation as a hydraulic engineer. With this, he was able to travel and worked across Germany and also in France. It was during one of his work across Europe that he advised on the expansion of the Stecknitz Canal and also worked on the Elbe-Weser Canal. During this expansion, he was able to devise an instrument that can be used to measure water flow. This instrument was later known as Woltman turbine-based flow measurement device. In 1896, Clements Herschel invented the Venturi Flowmeter. Prior to that time, Herschel's career was devoted to bridge design. This included the design of cast iron bridges. For a time, he was employed on the sewerage system of Boston. Herschel was influenced by James B. Francis was the agent and engineer of the proprietors of locks canals on the Merrimack River at Lowell, Massachusetts. He advised Herschel to switch his career path to hydraulic engineering. About 1880, he started working for the Holyoke Water Power Company in Massachusetts. He remained with the company until 1889. While he was there, Herschel designed the Holyoke testing flume. This testing was what marked the beginning of the scientific design of water power wheels. Herschel first tested his Venturi meter concept in 1886 while working for the company, and by 1888 felt he had perfected it conceptually, ultimately naming it in honor of Giovanni Battista Venturi, the eminent Italian physicist who first described the differential pressure phenomenon in a 1797 treatise. Ultrasonic flow meter was first discovered by Rutten in 1928. This invention relates to the method of manufacturing a toothbrush. A magnetic flow meter is also known as mag meter or electromagnetic flow meter. The mag meter device works on the principle of Michael Faraday's discovery on electromagnetic induction. When a magnet is held stationary at that position, the needle of galvanometer returns to zero position. Now when the magnet moves away from the coil, there is some deflection in the needle but in opposite direction. Faraday concluded that whenever there is relative motion between a conductor and a magnetic field, the flux linkage with a coil changes, and this change in flux induces a voltage across a coil. Now that we have known this principles, the device works when a magnetic field is applied to the metering tube. In 1977, Coriolis Flowmeter was produced in commercial volume. This flow worked on the principle of Gustave Gaspard de Coriolis' discovery. But before this type of device was produced at large quantity, Gaspard Coriolis projected an experiment in the late 17th century. Gustave Gaspard de Coriolis discovered the Coriolis effect, which is when observing cannonballs launch from north to south or from south to north. Each ball appeared to move in a curved trajectory, this trajectory bending slightly toward the east. And the opposite effect also occurs when experiment was repeated in the southern hemisphere, unlike the northern hemisphere that move eastward. In the southern hemisphere, the trajectory deflections tends toward the west. And as such, the rotation of the Earth and the location of the observer caused the visual effect. Therefore, the Coriolis force will exert itself on the objects. The exertion effect is due to Earth rotating along its axis. Since Gustave's observation in 1835, scientists have applied the use of the Coriolis effect to hydraulics, machine performance, and ergonomics as well as ocean and atmospheric circulations. With this discovery hence its name. I hope you enjoy some bit of history today. In the coming series, we will be looking at flowmeter, the common types of flowmeter we have, and its application in industrial setup.